like Hyakutake or Hale-Bopp. Now, those are brand new comets that nobody's ever seen before.
Right. Those are, again, from some of the earlier nomenclature where they're named after the discoverer. It gets more chaotic with modern comets, but since Pan-STARRS is finding most of them, we are glad for the chaos. Right. So, for instance, there is Comet 2017 K2 Pan-STARRS.
Perfect. Okay, so that's a jumble of information. What does that mean?
Yes. So that means it was found in 2017. The K2 starts to give you information on the where in a given month and which number in a given month it is that it was found. And Pan-STARRS is the discoverer. So in this case, it's just a telescope survey. Yeah, right. Yeah, it's kind of boring.
Boop. Right. So robots. So comets. So would you say that accurately that comets are named after robots?
Yes. And okay. I'm okay with this.
Yeah, I'm all right with that. That's fine. I mean, this really should smooth over the rise of the robots. Like when they come to dismantle us for our atomic parts, we'll say, whoa, we named all these comets after you. And they'd be like, you humans. Oh, shucks. All right. No Matrix for you. No termination. We'll live in peace and harmony till the end of time.
I don't think it's going to work that simply, but
it's worth a shot. Right. It's worth a shot.
It's worth a shot.
Yeah. All right. So now for the best part. We've talked about comets. Let's talk about asteroids. How do asteroids get their name?
My dog just sighed as well.
Good.
So asteroids get their name basically in the order they have been found. So it's asteroid 1, 2, 3, 4. And then sometimes, if they're a lucky asteroid, someone decides to grant them a name.
Yeah.
And again, the name has to be approved of by an International Astronomical Union committee. But in the past, we didn't have this committee. So you can go and look up like the earliest discovered asteroids, and they have the number and the name, and the IAU was not involved. Ceres, Vesta, they were just named.
But that's interesting. So when you see 4 Vesta or 1 Ceres or whatever, when you see the number, you know that it is...
What order it was found in.
What order it was found in. Yeah. And so, for example, asteroid, 158,092.
We haven't got that high yet, but
yes, we have. We absolutely have. Yeah.
Oh,
asteroid 158,092. Asteroid Fraser-Cain was the 158,092 second asteroid that was discovered.
All right. Fair. Fair enough.
Now, how did it get the Fraser-Cain part of its name?
So either the person who discovered it, or if it got ignored long enough, someone who noticed that it had been ignored long enough submitted to the IAU that this asteroid deserves a name. And this name I am proposing commemorates someone who is good and noble and has done excellent things and has a name that is absolutely not controversial.
Right. And so in this case, Jeff Metcalf, the blue-collar scientist who passed away
in 2008,
15 years ago, was a prolific asteroid discoverer and named asteroids after a whole bunch of people in the science and science communication community.
Yeah, you
got me,
Phil Plait got your names
Emily
at the same time.
Lakdawala, but missed you, and we're always sorry. So if anyone's listening to this and you discover asteroids, like throw a bone to Pamela. Come on, she could really use an asteroid named after her.
Well,
But so the point.
If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena High, the director of the Observatory, and I'm very, very pleased to be joined tonight by Sana Withers. We are broadcasting live from Allan at Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is, in fact, Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or Tuesday morning at around 2 a.m. UT, just in case you're in another time zone. The York Universe production works in concert with our online public viewing, run by our wonderful observatory team of students and volunteers. If you would like to, you can follow along. The hours run exactly with this show from 9 p.m. to 10 p.m. local Toronto time. Just head on over to observatory.info.yorku.ca and follow the links to OPV for online public viewing. Join in the chat and watch the images come up on the screen. It will take you to a YouTube channel, so if you would like to find us direct on YouTube with the OPV crew, just head on over to YouTube and enter in the Allan Carswell Observatory at York University. It should be the first one that pops up live. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. And if you have any questions or comments for this show or any future ones, send us an email at observe@yorku.ca. Just a little note, you can actually connect with us on Twitter as well. If you are on social media, we are over at York Observatory and York U Observatory on Instagram. Facebook, a little bit different, Allan Carswell Obs. And as a final note, all of our programs, including this one, are free, but if you'd like to make a donation, you can just see our website at observatory.info.yorku.ca. So our crew is monitoring the YouTube chat room for questions. Feel free to wander on over and say hi. In the meantime, we have a great show lined up for you today. We have all kinds of things going on, just both current and past. We're just talking about how interesting it is right now in astronomy. Sana, how are you doing this fine Monday evening?
I'm doing well. I'm definitely getting a little depressed looking at the weather forecast for the next week or so.
Yes, so many great things happening, and there are clouds. That is, I did note that we can still see the moon through the clouds, only just. We are heading for a full moon, and we'll probably talk a little bit about that later on. But yes, it is once again overcast in Toronto, playing havoc with all kinds of observing plans.
Oh yeah, but apart from the weather forecast, I'm doing pretty well. How about you?
Well, I am getting very excited for our observatory, actually. If anyone's following along, we have two beautiful new domes that landed atop the Allan Carswell Observatory earlier this year, and we're right now working on the robotic brain of those domes. They're going to have a fully programmable interface that works with the computers and actually aligns with the telescopes. So I was up, it was today, earlier today, putting in a new 30-meter long cable to stretch across and control one of the ports. It's really exciting times, and I just, as you say, just wish it would clear up, darn it. But, I mean, we can at least hope for some clear views of the moon, and I think that gets us pretty close to our first This Week in Space and Astronomy history. So do you want to start us off with a little bit of a lunar tilt, Sana?
Sure. So this is a good This Week in History item, given some lunar news going on in the past month or so. So it's kind of a two-part for about the same mission. So two events. December 7th, 1972 was the launch of Apollo 17. And then December 11th, 1972 was the anniversary of when Apollo 17 actually landed on the moon. So This was the 6th crew to actually go to the surface of the moon, and also the final crew to go to the surface. It was the last of the Apollo missions, and still now, 50 years later, was still the last time that a human being set foot on the moon, which is definitely disappointing, but hopefully will be changing in the coming years. How long we have to wait for that, I'm not too sure, but there are plans to change this, thankfully. The crew on December 7th launched aboard a Saturn V from the Kennedy Space Center, and this was the only night launch of the Saturn V. They launched, I think, around in the middle of the night. They had a few hours delay, but it was a really fantastic night launch. I think the night launches for rockets in general are kind of my favorite because they're just so pretty. So definitely an interesting aspect of this mission. So like all of the Apollo missions, their crew consisted of 3 people: Commander Eugene Cernan, Command Module Pilot Ronald Evans, and then the Lunar Module Pilot Harrison Schmitt. Eugene Cernan is kind of a veteran of the Apollo program. He also flew on Apollo 10, this time as the Lunar Module Pilot. And Apollo 10 didn't actually land on the moon. It was sort of the dress rehearsal for Apollo 11. So they went to the moon and did a sort of landing, but not really. They sort of did an approach of the moon, but actually never hit the surface. So he was, this time, actually got to walk on the surface of the moon as commander, not as lunar module pilot. And then Harrison Schmitt was actually a scientist astronaut, and the only scientist astronaut of the Apollo era. He's a geologist by training, and then later on became an astronaut after there was kind of a push for scientist astronauts in the space program. Right now, it's pretty common for astronauts to have some sort of science background, but back in the Apollo times and before Apollo, it was actually very common for astronauts to be pilots because they needed to be able to actually pilot a spacecraft and return to the Earth safely. So science had taken kind of a back seat on some of these programs, and most of the astronauts ended up being pilots. But there were quite a few scientists who were not happy about this because a huge point of space exploration and landing on the moon in particular has to do with doing science. So it doesn't really make sense to have a bunch of astronauts and none of them be scientists. It seems like some of the scientific community kicked up a bit of a fuss and sort of harassed NASA into hiring some scientists to become astronauts. And they were successful. NASA started hiring scientists as astronauts in around the 60s. But despite that, no scientist astronaut flew on a mission, an Apollo mission at least, until 1972 on Apollo 17, when Harrison Schmitt was selected to be on the crew. He was originally supposed to fly on Apollo 18, not 17, but when Apollo 18 got canceled, the management kind of decided that there was no point in having scientist astronauts if none of them are going to fly. So they removed the former lunar module pilot, Joe Engle, and replaced him with Harrison Schmitt. So there would finally be a scientist actually going and walking on the moon. So definitely an exciting thing to have the first scientist astronaut on Apollo 17. But anyways, the crew ended up exploring this Taurus-Littrow area on the moon. It was the place they went to in particular was this valley in the Sea of Serenity. I've seen it be described as probably the most complex or geologically complex of all of the Apollo landing sites. This is because it gave them opportunities to study two different epochs in the history of the moon. So first of all, there was a possibility of being able to find some of the youngest samples that had ever been taken from the moon. This was in part because this area had formed before the Imbrium impact. So if you study that area of the moon, you could see what the moon looked like before this major impact that had really shaped a lot of the other areas of the moon that the Apollo astronauts had gone to. So it definitely gave them sort of a view into what the moon looked like in the very, very far in the past. But it also gave them an opportunity to study volcanic activity in the moon's recent history. So some images that were taken on Apollo 15 of this Taurus-Littrow Valley showed that the surface was covered in this very dark material, some of the darkest material that they had seen on the moon. And geologists at the time had kind of speculated that this could be volcanic ash from fairly recent volcanic activity on the moon. So fairly recent isn't fairly recent in human terms because the moon isn't volcanically active anymore. But in terms of the moon's history, that volcanic ash that is on the surface was pretty young. So it was sort of a good place to go, packed with a ton of interesting science that they could do. The area was kind of hard to get to because it is in the middle of a valley, and you obviously don't want to be landing on kind of the side of the valley for safety reasons. So it was definitely a tricky place to go to, but the crew were able to get there successfully and then come back to Earth. And it was definitely paid off going to this area. So the crew had accomplished a ton of the science goals that they had. They ended up collecting one of the oldest rocks of the entire Apollo era. I'm totally going to butcher this name, but I think it's called Troctolite 76535, which was, according to NASA's, the oldest unshocked rock that had been recovered from the surface of the moon during the Apollo era, at an age of 4.2 billion years old. And the interesting thing about this rock is that it showed that at some point in the history of the moon actually did have a magnetic field that was created by a dynamo in the core. So this is kind of similar to the way that the Earth generates its magnetic field. In terms of the more recent history of the moon, they also discovered this sort of black and orange soil that turned out to be volcanic ash. It was generated during this really violent volcanic eruptions on the surface, and it spewed this material sort of all around this crater, which was evidence of fairly recent volcanic activity on the moon, kind of what they had expected to find there. On top of all of that, the crew had also deployed 10 different experiments. This included the Apollo Lunar Surface Experiments package. It's a suite of instruments that does quite a few things. There was one of those deployed on each one of the Apollo missions that went to the surface so that you get data at multiple different points on the surface of the moon. The crew also took core samples, and this, combined with the other samples that they collected on the moon, allowed geologists to discover that the moon is more chemically diverse than they had expected it to be prior to Apollo 17. So since this was the last mission to the moon and every one of the Apollo missions sort of kept growing in complexity, this crew still holds the records for several things related to lunar exploration. So they have the longest time spent on the surface, which was 75 hours. They have the longest time spent moonwalking, 22 hours in total, where they covered over 35 kilometers and visited 22 different locations to collect samples. And Ronald Evans, who stayed in orbit in the command module while Harrison Schmitt and Gene Cernan went to the surface, holds the record for the longest time ever spent in lunar orbit by a human. And so pretty interesting, definitely kind of sad that it's been 50 years and we haven't gone back to the moon. But at the end, one thing I do also want to mention is at the end of their final moonwalk, the crew left this small plaque on the moon where they landed that says, "Here man completed his first exploration of the moon, December 1972. May the spirit of peace in which he came be reflected in the lives of all mankind." So happy launch anniversary, and I don't think there's a happy anniversary term for landing on the moon, but happy launch anniversary to Apollo 17.
Absolutely. And such a wonderful mission to talk about right now when we've seen, the images from Artemis come back. And it's right now is its own amazing time in history because, of course, right now we have seen NASA's Artemis mega rocket launch Orion to the moon in an effort to duplicate what was done back in 1972 and previous. And it's actually, very much we're following the same formula. The Artemis, of course, launch was successful. And even to the extent of, as you say, they did a night launch of their Saturn V in 1972. Well, the Artemis launch, we can all remember how delayed that was until they finally got the launch out successfully. And now they've gone around the moon. beautiful images of crescent Earth out there for folks who might be wanting to go do a Google search. And that was an uncrewed mission. And the next one is going to be flying around the moon with people, but no landing. And then, of course, we have the Lunar Gateway to look forward to, and hopefully, fingers and toes crossed, a more permanent moon exploration, with regular visits that any of us can go to and hang out on, and I can buy a ticket. So, if enough people go, we'll all be able to get tickets. They did say something about wanting scientists, so I think we have a chance, Sana.
Yeah. It would be fun to go to the moon, I think.
The lack of gravity. Like I say, I still think basketball on the moon. That's the way to do it.
Yeah, sorry, I had actually read that when Eugene Cernan and Harrison Schmitt were on the moon, they did a bit of goofing off, and they were kind of kicking rocks places and skiing down some of the slopes on the moon, sort of hopping, skipping around, and in 1/6G sounds like a lot of fun. So
yeah. Well, and of course, back in Apollo 14, you had Alan Shepard hit 2 golf balls. So, if you give people a little bit of free time, all of a sudden it just gets super, super fun. And all things considered, they spent 75 hours on the surface, as you say, but that's not so long. I mean, I could spend 75 hours bouncing around.
Oh yeah.
And of course, where they landed was really interesting for the rock types. But one of the things that has changed since 1972 is that now we know the moon does actually have water on its surface, and lunar water has been mapped a couple different ways since then, in all kinds of really cool ways. And it was not until well after they had left the moon, and they hadn't been back in quite some time, we had the Deep Impact NASA's probe in 2005, which I believe, and I'm not totally sure on this, it seems to have been named after the movie, but it was a probe that was sent off to crash into the moon, and it had 2 sort of pieces, if you will. It had an instrument impactor, which it means we're going to impact on purpose, and they were going to look for water. And the first detection of lunar water, sure enough, is cited by them. So before we had some suspicions about the existence of water on the moon, there Cassini, we have different kinds of, I'm sorry, not Cassini, but I was trying to say Clementine. The military probe Clementine from the U.S. military had a radar experiment, which actually had echoes of, would bounce off of ice differently than rock. But it was very, very inconclusive, and that was back in 1994. So in 2005, when Deep Impact actually registered real, possible ice, it got everyone very, very excited. And of course, then we had the lunar mapping program from Japan, the Cayuga program, I think, and it had gamma ray spectrometry, which is some of the same technology we've used on Mars. And of course, water ice. Why am I getting so excited about water ice? Well, this Cayuga probe actually, was looking to study different kinds of ejecta, and just like I said, everyone started getting very, very excited, because water on the moon means that we can stay there easier. So 72 hours with no water is a bit challenging. I mean, I'm assuming the astronauts had some way to take drinks of something. But if we have water on the moon, we can actually have people staying there for longer amounts of time, maybe even setting up permanent bases. And so Chang'e 1 from China in 2007 took photographs of those exciting polar areas where water ice is likely to be found. And then finally, it was India's spacecraft, Chandrayaan-1, more recently, that actually had some presence of water ice detections. And I believe they recorded something like 650 different images across the moon. And now we know that there are conclusive evidences for water ice in some of these craters that never get sunlight, and where we have permanent shadow on the moon, which is already just a cool thing to say. Those areas of permanent shadow. But the moon is all of a sudden not just more reachable with Artemis, but more livable with the discovery of water and lunar ice and lunar water, and being able to do things with water means that we have, chemistry that we can process on the moon. And maybe building a moon base isn't such a crazy idea after all. So I just love the fact that we're now able to look at the moon in maybe not the same way that we were looking at it back in 1972, but with the same excitement and with new chances of getting out there and maybe even finding a nice crater full of ice and setting up some sort of cool moon base.
Yeah, and loads of scientists that are astronauts now, which
yes,
is helpful for a lot of science.
Yes, exactly. And that there are now so many more trained scientists. And that is the other thing we've seen in the last few years. And even just the last 1 year, so many members of the public, even without aeronautics training, without pilot training, some of them had science training, some of them didn't even have science training, but they're able to still go on these launches from, Blue Origin and SpaceX and Virgin Galactic. And so the fact that it has become more accessible as well means that now you can do more science if you want to, which is really just lots of fun.
Oh yeah.
Well, speaking of fun. Let's go out from the moon and zip on to the same year, actually. So 1972 and December are both really good times for astronomy, because in 1972, the other thing that was happening was Pioneer 10, the first spacecraft ever to visit Jupiter. It arrived on December 3rd, 1973, so I guess there goes my 1972 foray. So this spacecraft would also find a lot of interesting stuff. So Pioneer 10, being launched in 1972, it arrived at Jupiter on December 3rd, 1973, and Pioneer 10 was a really interesting space probe. This was uncrewed, as has been most space vehicles. This was launched by the U.S. and it had, was 260 kilograms, but it had the first mission to the planet Jupiter. And it was also the first of 5 sort of human-made artificial objects to achieve the escape velocity needed to leave the solar system. So it's on its way out, and it's been going for quite some time. So it started taking pictures of Jupiter on November 6th, and it had its sort of closest approach on December 3rd. So the closest approach of Jupiter was at about 132,000 kilometers or so. And during the mission, it was used to study the asteroid belt, the environment around Jupiter. We looked at the solar wind, we looked at cosmic rays, and of course, as it's going out of the solar system, we're actually able to get some sort of measurements of the heliosphere, which is this sort of outermost atmospheric layer of the sun, sort of the farthest reaches of our own star. So Pioneer 10, we do not currently have radio contact with. We did actually lose radio contact in 2003 because we think it lost electric power for its radio transmitter. And at that time, it was about 80 AU, or 80 times farther away from the sun than Earth is, which is about 12 billion kilometers. So it's still going, but we don't have contact with it anymore. And of course, the Pioneer 10 flyby of Jupiter really was absolutely astonishing. These first glimpses of the red giant planet, and it really had a lot of sort of captures the imagination. And of course, Jupiter itself having the moons, Europa and Callisto and Ganymede with water. I would mention Io, but as far as we know, there's no water on Io. I could be wrong. Planetary scientists, you could email me later. It was a really, really, really interesting mission. And Pioneer 10 has, technically been going for 30 years. I mean, we haven't had contact with it for a while, but it's quite the mission. And, the fact that it was the first to fly past Jupiter. It was also the first to go beyond Mars. It was the first to go through the main asteroid belt. And at that time, we actually didn't know a lot about the asteroid belt either. We didn't know how dense it was, if it would be a danger to spacecraft. And of course, now we know it's incredibly not dense. I mean, just with comparison to the rest of the solar system, it's dense, but there's almost no risk of getting hit by anything. And of course, Pioneer 10 was also the first to cross the orbit of Neptune and go beyond. And it did use all nuclear electrical power. So it wouldn't be running out of like solar power as some other crafts might. As you get too far out into the solar system, of course, you get less and less energy from the sun. So Pioneer 10 and Jupiter is just an amazing time. So it was really, really fun mission, really great to think about it going past. And in conjunction with Pioneer 9, it actually also got to view some really violent solar storms. So it had all kinds of wonderful firsts. And the Jupiter, I think, is probably one of my favorites, because it did get photos of Callisto, Ganymede, and Europa. It actually didn't get any pictures of Io because the photopolarimeter that it had on board had succumbed to radiation, which is one of the reasons why we were able to tell very quickly that the radiation around Jupiter is pretty intense, and the Jupiter environment is somewhat hostile due to its high magnetic field and accelerating particles from Io, among other things, to create incredibly high radiation belts. So this was all happening in December, and it's actually a December coincidence, because in Pioneer 11, the mission after that, it actually had the same mission as 10, and it arrived at Jupiter on December 2nd, 1974. So a day earlier and a year later. So that's Pioneer 10 on December 3rd, 1973, and then Pioneer 11 a year later and a day earlier on December 2nd, 1974. So Pioneer 10 and Pioneer 11 are obviously, interrelated heavily. And the Pioneer program itself is so cool. And it's so exciting, because when you look back at these old historical programs, I just want to tell you, the first Pioneer mission, Pioneer 0, failed 77 seconds, say that 10 times fast, after launch. So it failed mere seconds after launch. Pioneer 1 was a third stage partial failure. Pioneer 2 was a third stage failure. Pioneer P1, which was the next one, lost its launch vehicle. And then finally, you had Pioneer 3, and then for some reason they skipped 4 and went to 5. Pioneer P30, which comes after 5, failed to achieve lunar orbit. It was a lunar probe. And, so we had failure, and success. And so it took a lot of perseverance and a lot of determination in the face of, not instantaneous results, which is something that's worth kind of remembering in this modern era where everything has to be fast. Pioneer 10 and 11 were the results of a lot of work and a lot of things that did not work before they came along. So Pioneer 11, we actually do still have signal from, I believe, and it is out there in the solar system. It's currently 22 years in length, a little bit less length than Pioneer 10 because it's launched later, and it's on a trajectory that will also take it out of the solar system. And actually, Pioneer 10 and 11 and Voyager 1 and 2, they all carry a message from humanity to the cosmos, and they're all headed out into the solar system. They're not headed in any particular direction. Pioneer 11 is thought to pass near to star Lambda Aquila in about 4 million years. So I wouldn't hold your breath hearing anything back from them. But it's still really interesting that these early missions came out and had so much success and provided so much to, of course, not just Jupiter, but the whole solar system. And of course, the moons of Jupiter and the water on the moons of Jupiter is, I would say, if not as interesting, maybe even more so than the water on our own moon.
Yeah. I'm a little surprised that they started the Pioneer program with Pioneer 0. I didn't know that.
Yeah, I think this goes on the same level as astronomers are bad at naming things. So are space astronomers. There are some very strange naming conventions out there, and I don't know exactly where that one comes from, but it's like when you have a file name and you keep adding things onto the end of it, perhaps.
Yeah, and the what was it, the P1 and P0, but skipping 4? That's really weird.
Yeah, the Pioneer program had a lot of different phases, and so it had sort of an early phase and a late phase. The later missions contained the Pioneer 10 and 11, and the early phase obviously had a lot of the testing objects, really. It's we don't have good contact with either of the Pioneer probes anymore, but we can tell approximately where they will be based on their speed and where they were headed. But the current mission duration, we still count them as sort of active because they're still going. 49 years and 8 months for Pioneer 11, and even more for Pioneer 10. I don't think we've had any good engineering data for quite a while, though.
It's still remarkable that they're still going after the.
Yes, and we will hear more about that. That is one of the things with these programs. They tend to get extended and extended and extended because these crafts, when they succeed, they're so incredibly robust. We keep being able to use them, so we keep using them. And so you'll see a lot of times, not just around Jupiter or the moon, but even Mars crafts long outliving their expected lifetime. I believe there's another Jupiter mission that also did extremely well. So if you want to use that as a segue, Sanai, we can go to another Jupiter spacecraft.
Yes, that's a good idea. So December 7th also seems to be a good day in astronomy because this was December 7th, but 1995 this time, which was when the Galileo probe arrived at Jupiter. So this was a NASA-run mission, which was a Jupiter orbiter. So like you had mentioned before, Pioneers 10 and 11 had both visited Jupiter. On top of that, Voyagers 1 and 2 did as well, but those were all just flyby missions. And this Galileo probe was the first spacecraft to be not only to be put in orbit around Jupiter, but to be put in orbit around any of the gas giant planets. So putting Galileo in orbit around Jupiter just kind of really expanded the kind of science that could be done, because it provided these longer term observations about of Jupiter and that system than you would be able to get just with a flyby. On top of being the first Jupiter orbiter, this was also the first mission to include an atmospheric probe to any of the gas giants. So on top of the orbiter, also on December 7th, 1995, there was this little atmospheric probe that Galileo sent directly into Jupiter's atmosphere, just plunged into the atmosphere to take data about like things like the atmosphere composition, weather, and things like that on Jupiter. So the spacecraft spent in total about 8 years in orbit around Jupiter. It did a ton of amazing things. So just a couple science highlights, because we don't have time to talk about all of it. The Jupiter probe, the atmospheric probe, and Galileo kind of worked together to study things like weather on Jupiter. So it discovered that Jupiter has these massive thunderstorms, several times larger than the Earth. I think this kind of makes sense because Jupiter is, maybe this is simplifying, but it's basically one big storm in a lot of areas. So it kind of would make sense that it has these massive thunderstorms. The pair also measured the atmospheric composition of Jupiter. And this had some pretty interesting results, because one of the things that they studied was the elemental abundances in Jupiter. And since the sun and the planets sort of co-evolved and formed together, what you would expect is that the elemental abundances of the sun and Jupiter are the same because they formed out of the same stuff. But Galileo discovered that the elemental abundances are slightly different. So this does show some evidence of evolution of Jupiter independent of the sun after the two had formed. The probe also was able to take a lot of observations of Jupiter's rings. It has this very, very thin and faint and dark ring around Jupiter. It's kind of, I don't think you can see it from the ground at all. I might be wrong about that. But these ring systems are very, very hard to see. But since Galileo was at Jupiter, it was able to really take some really amazing observations of these rings. And it discovered that the rings form as a result of collisions between meteoroids and the Galilean moons. So when a meteoroid smashes into one of the Galilean moons, these are the 4 largest moons in orbit around Jupiter, it sort of ejects material, it gets spewed into space, and eventually that material will start to orbit Jupiter and form the rings. So on top of all of those really, really cool discoveries about Jupiter itself, I think probably the most interesting observations come from what it discovered about the moons of Jupiter. So it was the Galilean moons in particular, Europa, Ganymede, Callisto, and Io. It did flybys of each one of these moons more than once during its mission. And it really revealed that each of these moons, even though they're pretty small, they really are their own interesting and dynamic worlds. So just a couple of the highlights on this front is that it discovered that Europa has this global subsurface ocean full of liquid water. It discovered that Ganymede and Callisto have liquid water, salt water on their surfaces. So Europa, I don't think, has the ocean of salt water. It's just plain liquid water. But Ganymede and Callisto have salt water in particular. It discovered that Ganymede has a magnetic field, which was the first known moon in the solar system to have a magnetic field at the present time. It discovered that Io is volcanically active, possibly 100 times more volcanically active than the Earth, and is also the only other body in the solar system that we know of that has current volcanic activity. Finally, it also discovered that Europa, Ganymede, and Callisto have thin atmospheres. So it's nothing very strong, but it is a very, very thin atmosphere. So each of these moons, it's really crazy that these relatively small things can be just so dynamic and so interesting. So I think those are probably my favorite science highlights from the Galileo mission. But just to note here, it took Galileo around 8 years to reach Jupiter. So while it was on its way to Jupiter, it was doing a lot of science even before it had even arrived. One interesting thing that it did here was that it did a flyby of the asteroid Ida in 1993. And during this flyby, it discovered that Ida had a small moon in orbit around it named Dactyl. This flyby made Galileo the first spacecraft to do a flyby and imaging of an asteroid in the asteroid belt. And then not too long before it actually arrived at Jupiter in 1994, it observed this collision between comet Shoemaker-Levy 9 and Jupiter. So this Shoemaker-Levy 9 just slammed into the atmosphere of Jupiter, left these huge marks in the atmosphere for a period of time. It was visible from the Earth. This is the only direct observation of a comet colliding with a gas giant like that. And Galileo was able to image that in space, which was the only time a spacecraft as well had observed something like that. So the Galileo mission ended up coming to an end in September of 2003. There's now another spacecraft in orbit around Jupiter, the Juno probe, which is doing a ton of amazing things as well. So definitely very interesting discoveries from an amazing spacecraft.
Absolutely. Such a fun mission too. And it really provided so much detail that we didn't have before. It's hard to overstate just how much this changed our idea of what moons could be. And especially, I think, Europa has really captured the imagination of a lot of people. I think, as you say, the ice and the water that's on Europa, we've so far only measured remotely. But, whether or not you could have life forms in the oceans of Europa, well, we don't know. I mean, if it is too salty, you could only have extremophiles. Well, if it's like Earth life anyways. But they have actually detected clay-like minerals, sometimes called phyllosilicates, on the icy crust of Europa, which are sometimes associated with organic matter on Earth, but we don't know. So as far as I know, the Europa Clipper is still scheduled to be launched in 2024. So mark your calendars. Although once it launches, it will take a while to get there. So it won't actually get into Jupiter orbit until 2030. But it's set to do a whole bunch of flybys, close flybys of Europa with detailed measurements to see whether or not it really could have life, and maybe answer some of those questions about, is it a thin ice crust on Europa with a big ocean, or is it a thick ice crust with a little ocean, and how cold is it, and maybe make some measurements of that thin atmosphere that you mentioned. So yeah, it's so exciting because of just the amount of water that could be liquid on that moon, and because of its density and the composition of Europa, we can actually tell that the amount of water on there is actually larger than all the oceans of Earth. So if you rolled up all the oceans of Earth into a ball and compared that to the size of all the water in Europa, Europa would have more water.
Which is so much smaller than the Earth. So
yes, and exactly, and it's so much smaller than the Earth. So I mean, if it does have big ocean, and we all know how life teems in the oceans here, it just gets really, really exciting. It's just that water out in space, boy. Very, very exciting stuff. All right, so before we go off to our last This Week in History, let me go ahead and remind everyone, you are in fact listening to York Universe. We are broadcasting live from the Allan Carswell Observatory tonight, located at York University in Toronto, Ontario, Canada. If you'd like to hop on to OPV, or online public viewing, and follow along with the Observatory team, that is at observatory.info.yorku.ca. You can join in the chat on YouTube, ask questions, or of course you can also find us on Twitter at Yorku Observatory. Tonight you're listening to Elena and Sana, and currently we're discussing water and Jupiter and all kinds of other fun stuff. So let's see here. Shall we finish off our This Week in Space and Astronomy history? Let me take us, speaking of water, let me take us to 2006. So I'm going to go for a little bit more recent history, not too long ago. But speaking of water, we've talked about the moon and we've talked about Jupiter, and a little extra side note on Europa. How about Mars? Aha. Well, in December 6th, 2006, NASA images came in which suggested water flowing current day on Mars. This was from Mars Global Surveyor. So the Mars Global Surveyor, in case you didn't know, this was a really fun mission. It was actually launched all the way back in 1996. And it was a global mapping mission that was going to examine the entire planet Mars. So looking from the ionosphere all the way down to the surface. And as part of the Mars exploration program, the surveyor would look at the atmospheric monitoring, and it could also help rovers and landers by identifying sites and just do a really, really good mapping. So Mars Global Surveyor's actual mission was a little more complicated than just looking for water spouts. It was actually looking for possible landing sites, in particular for the Phoenix spacecraft, which is a little bit of a sad story, but it did quite well. The Curiosity rover landing site as well, and it would also look at geological processes on Mars, because Mars has seasonal dust storms. Its surface changes over the course of a year. So what else changes? What kind of other geological processes do we currently have on Mars? It was also looking at surface minerals, rocks, ice, topography, even the gravitational field, and looking at that crustal remnant magnetic field. So Mars has a residual magnetic field, which actually has different strengths depending on where you are on Mars. It does not have an active magnetic field currently, which does mean that it would be you would have to worry about radiation on Mars. So Mars Global Surveyor is a great mission. It was out there for 10 years. So it actually spent 9 years in orbit about the red planet. Took about a year to get there. It used aerobraking, and it sent more than 240,000 images for Earth. So even though the mission ended in 2006, it has provided us landing sites for a lot of the rovers that we have now on the surface. So Spirit, Opportunity, Curiosity, the Phoenix lander, all those sites were scouted with this orbiter. It was also actually, interestingly, the first spacecraft to use aerobraking to enter orbit at Mars. So it was running at good pace until, of course, we lost connection with it. So we did lose connection on November 21st, 2006, which was the last contact with the Mars Global Surveyor. So the Mars Global Surveyor released this wonderful little press release November 7th, launched November 7th, 1996. So there's a lot of Novembers in Mars Global Surveyor. So I could have put the launch date as well, actually. And it found gullies and debris flow features, which indicated current sources of liquid water on the surface, similar to what we call an aquifer here on Earth. So this would be at or near the surface of the planet and would mean that liquid water could come to the surface. It can't survive on the surface, so once it gets there, it has to choose sort of whether to sublimate into the atmosphere or to sort of freeze back into the crust. But this mapping was some of the most exciting Mars water, I suppose, images of the time, and I actually can remember these coming in. So September 2005 was one of the most famous Mars Global Surveyor images, and this was a difference photo. So that because it had mapped the surface, it would go back and remap the surface again, and it could see changes that had happened. And between August 1999 and September 2005, there was actually new deposits, bright new deposits inside gullies on Mars, which suggested water carrying sediment through them at some time between the two images, which was 7 years. So at some time in between those two 7-year or two images taken 7 years apart, something happened to create something that looks an awful lot like water carrying sediment through the surface of Mars. And this got everyone very, very excited about Mars again. And if you know me at all, you know I'm already very excited about Mars, because watching deposits which are looking like they've been carried by flowing water. They have the finger-like branches at the downhill end. They're diverted around small obstacles, and it behaves exactly like you would expect to behave, water being carried in a thin, cold atmosphere. So it's going to rapidly evaporate or freeze, so you don't get long flows, but it could remain liquid long enough after breaking out that it could carry debris downslope before freezing out and maybe being either, as I say, absorbed back into the surface or sublimating into the atmosphere. So really, really cool stuff. Mars Global Surveyor and water. So you're thinking about, going to Mars after the moon, for example. Perhaps you're thinking about the Lunar Gateway and Artemis and the moon base, and then from there going on to Mars, as some people are. You would want to know where those water outgassings would occur, because once you have water, you have a wonderful natural resource you can use. So as I say, speaking of water, I just had to put that one in as well. So I think we have one or two reminders for everyone tonight. I definitely want to get to those before we do the Titan news article. So we will be doing a rerun on our Observatory Teletube this Wednesday. It will be a blast from the past because, of course, this is the beginning of finals week, or finals month, I suppose, for York University students. So our crew will be taking Wednesday off. We will replay one of our wonderful episodes for you, and then next week we'll be back with a regular show. However, just because we're not doing a show on Wednesday, that doesn't mean there's nothing to see. This Wednesday is a absolutely magnificent occultation of Mars by our moon. And if you're in Toronto, Ontario, Canada, you can watch it on Wednesday night around 10 p.m., 10:30 p.m. Watch Mars go behind the moon. It's beautiful and red and shiny, and it goes behind the full moon, so it's a full moon on Wednesday, and it's wonderful to watch even if you don't have binoculars. If you do have binoculars, you'll get a fabulous show. All we need are just some clear skies. Sana, do you want to talk about the splashdown?
Yeah, so just a quick reminder that Artemis 1 is scheduled to splash down on Sunday, December 11th. It should be around 12:40 p.m. expected. I assume these are subject to change if something does come up. So I guess if you want to watch that, just keep an eye on NASA's social media. I'm sure they'll be posting a lot of updates on there. But it is expected on December 11th, this coming Sunday.
So much going on up there. Oh my gosh. Well, I think we have time to talk about one more really, really fun thing. There's just too much exciting things happening. JWST and Keck. Oh my gosh. Speaking of unique, awesome things with liquid and I'm not going to say water, but ice.
Yes. Yeah. So JWST and Keck recently teamed up to do some fantastic observations of Saturn's moon Titan. So just like Jupiter's 4 Galilean moons are all really awesome, Saturn's largest moons are no exception. They are all awesome as well. Titan in particular is really unique among things in our solar system because it has a very thick atmosphere and also has these flowing rivers, lakes, and seas, not of water, but of methane and ethane. So it's definitely a really interesting and dynamic place that you want to study if you want to learn about so many things. The issue is that observing Titan is kind of hard because of its atmosphere. It's the thick atmosphere reflects visible light a lot. So if you want to observe it, you have to use infrared wavelengths because the atmosphere is at least partially transparent to some or most infrared wavelengths. And this is where JWST comes in. Because it's an infrared telescope in space and has a huge mirror, it can actually see through the clouds and be able to resolve surface features on Titan. So there was a team of scientists who ended up using JWST to observe Titan. They got their first set of observations on November 4th. And these images from JWST are just so cool. There are some of them that pierce through the clouds completely, and you can see surface features on Titan. So they saw a methane sea, sand dunes, and this albedo feature. It's kind of a dark patch that's on the surface. And on top of that, some of their other observations didn't entirely pierce through the atmosphere, and they were able to observe the lower atmosphere of Titan. Now, one super interesting thing that was in all of these images is that you can see 2 clouds in the northern hemisphere of Titan. So that discovery of the clouds kind of made things a little bit more urgent, because one of the cool things that you can do is if you can get follow-up observations within the right time period, you can actually see if you can watch the clouds as they move and if they evolve at all. So once this team realized that they had these 2 beautiful clouds in their observations, they immediately said, we need to get follow-up observations so we can see what these clouds are going to do in the coming days. It wasn't possible to get JWST follow-up observations for these because the process is kind of long and takes a lot of effort. But they did have some collaborators at the Keck Observatory that they reached out to, and they ended up kind of throwing together some last-minute observing plans and rescheduling some of the observations that were supposed to have taken place, and got follow-up observations to watch the clouds on Titan as they moved. So these follow-up observations were taken 2 days later on November 6th. The results are super, super cool because you can still see 2 clouds in the same place as those original clouds that were detected on November 4th. However, the one thing here is that we don't actually know if they're the same clouds that were observed on November 4th because the clouds do evolve fairly quickly. So it is possible that they are 2 new clouds that happen to come up in the same place, but it's also possible that those are the same 2 clouds that they saw on November 4th because they're in the same spot, but they do have different shapes. So it is possible that they just observed clouds evolving on Titan. So it's very, very important results because they can use it to study things like their weather models on Titan and also study seasonal weather patterns as well. So definitely very interesting results coming out of JWST and the Keck Observatory. And there are more Webb observations to come. They already have some near-infrared spectrums of Titan, and they will be getting some spectrums in the mid-infrared in May or June of 2023. So definitely something to keep an eye on. Lots of really interesting things coming out of this.
Absolutely. And Titan is, of course, a wonderful study case because we have actually, been there. And if the Cassini probe, gave us enough information that if we can understand how JWST is working for Titan, we might be able to explore, Neptune or Uranus or some of their moons. It's just so cool. And of course, just these moons are absolutely amazing, and Titan having the only atmosphere with clouds in it. It's just fabulous.
Absolutely.
All right, folks, I think that is all the astronomy fun we can cram in this hour. So I'm going to have to say thank you all. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Elena and Sana. And stay tuned because it is in fact Astronomy Night in Canada. You can always connect with us on Twitter at the handle @YorkUniverse, and check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe. Clear skies and have a good night.
Have a good night.
That you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.